Hello, I'm Charlie Murray, President and founder of SwitchSource. Here at SwitchSource, we make power electronics equipment for distribution utilities, and we're really focused on three things: how we can improve the reliability, the efficiency, and the solar hosting capability of the grid. Here we have a simplified representation of a distribution system. We have a distribution substation on the left-hand side, which is stepping down power from the transmission level to the distribution level grid. We have two distribution circuits, each of which could serve as many as 1,000 customers. And I want you to notice two important things. One is that power flows in one direction down these distribution circuits, from the power source out to customers. And the second is that each customer only has one tie back to the power source. So what happens when a tree falls on a line? You can see here that customers are left without power. The way that utilities mitigate this issue is by having feeders bump into one another at tie switches. These tie switches can be manipulated to restore service. They are only used during emergencies or every 3 to 5 years to reconfigure the grid. At SwitchSource, we saw this as an underutilized feature of the distribution grid. Now you might be looking at this and saying, well, why don't utilities just leave these switches closed all the time? Wouldn't that provide a networked distribution system and provide more reliability and DG hosting for customers? The problem is loop flows. When you close this switch, you expose this circuit to loop flows. Loop flows are a dangerous grid condition where the grid can easily become unstable and damage equipment both on the utility and customer side of the meter. The problem is utilities do not have control over power flow. That is, until today. What SwitchSource has developed is a medium voltage power flow controller. This device sits at existing switch locations and it acts a little bit like a controllable valve or an internet router for the grid. It's able to route power exactly where it's needed most to increase the reliability of the grid, but also to increase the amount of electric vehicles and distributed solar that can be connected to the grid. The tie controller is effectively adding another control point for grid operators. This is critical for them as they look to manage the grid during new reliability issues, as well as more distributed generation like rooftop solar and electric vehicles. In conversations with utilities, we found that our power flow control technology is not only useful for balancing between different distribution circuits, but also in between the three phases of an individual distribution circuit. Historically, distribution circuits are set up in three phases to take advantage of three-phase power, and each phase feeds as many as a block of homes. Utilities often have up to 200 meters on a single phase, but they can't be balanced without taking an outage and manually swapping wires. The phase EQ automates this process by routing power from phase to phase as needed. This is a completely automated device that routes power based on what it senses at the points where it's connected to the grid. One of the great things about working with utilities is that there's a tremendous amount of information in the public domain. Utilities have to justify their capital expenditures to state-level regulators, and thus have to show the benefits-cost analysis that they perform for every investment. We're able to take this same math that utilities use and apply it to the benefits and costs of our technology. And when we do, we come up with over $1 million in savings per device deployed in the field. SwitchSource's technology was originally invented at Michigan State University. SwitchSource has since licensed this technology and has the exclusive license for all fields and all territories. The secret sauce of SwitchSource's technology is its cascaded modular architecture. This architecture allows us to use commodity power electronics components, which are less costly, in a form factor that is much smaller than other potential topologies. The electric utility market is huge. As we look at the United States market, there are 200,000 feeders operated by utilities. This is a very consolidated market. 100 utilities represent approximately half or 100,000 of these feeders. Each feeder is an opportunity for us to install a device. Right now, we're focused on those feeders with the worst reliability issues. Anecdotally, this is about 5% of feeders, or about 10,000 circuits in the United States. SwitchSource prides itself on having great lines of communication to our customer base. We've already talked to 100 utilities, we've had 40 utilities that have done some level of technical due diligence, and now we have over 1,000 customer-identified projects. These are specific GPS locations where utilities have identified they want to put a SwitchSource device. From here, we've had 5 utilities that have committed at some level to a demonstration project and 2 fully contracted demonstration projects. There are lots of different technologies that are fighting for a slice of the distribution automation market. At SwitchSource, we know that we're not a silver bullet that's going to solve every utility's problem, but we do think that we're a valid solution that should be evaluated for a number of different use cases. We like comparing ourselves to energy storage because we can perform about 75 to 80% of the use cases that energy storage is used for at about 5 to 10% of the cost. SwitchSource has been fortunate to assemble a great team. The executives include people with experience developing the largest fleet of energy storage projects in North America, leading global research teams for GE in power electronics, and managing international teams for contract manufacturing for Dell. In addition to these individuals, SwitchSource has put together a great team of partners and suppliers. These suppliers are used to helping companies like ours figure out the best way to assemble their product so that it's easy to scale. And our partners have helped us develop a medium voltage utility grade piece of equipment that is both safe and easy to install. At SwitchSource, we have been very fortunate to receive support to retire a good amount of the technical risk and pay for a lot of the non-recurring engineering costs associated with developing our technology. Looking forward, we're trying to find strong partners to help us put demonstration projects in the ground to help us scale with utilities. We're also looking for partners that can help us with financing our Series A funding round. We're SwitchSource, improving the last mile of electricity delivery.